We're solving problem 23 from the 2021 AMC 12A. Frida the Frog begins a sequence of hops on a 3x3 grid of squares, moving one square on each hop and choosing at random the direction of each hop, up, down, left, or right. She does not hop diagonally. When the direction of a hop would take Frida off the grid, she wraps around and jumps to the opposite edge. For example, if Frida begins in the center square and makes two hops up, the first hop would place her in the top row, middle square, and the second hop would cause Frida to jump on the opposite edge, landing in the bottom row, middle square. Suppose Frida starts from the center square, makes at most 4 hops at random, and stops hopping if she lands on a corner square. What is the probability that she reaches a corner square on one of the 4 hops? So she says the problem states that you can make at most 4 hops. And, well, you can't get to a corner if you do 1 hop, because the problem says that you can't go diagonally. And let's just depict this. If you have 3x3 and she starts at the center, she starts here. Well, you can't hop diagonally, so you can't make it in 1 hop. That means we have to consider the cases of hopping 2, 3, and 4 times. And so let's start out with 2 hops. There is one way this can be achieved when she hops to the edge and then to a corner. And now all these symbols are just gonna denote like movements. For example, capital E is edge, capital C is corner when she moves to a corner, W is wrap around, and let's say O is when she returns to center, if she does. So let's move on with this case. Well, there's 4 ways to get to an edge, and then there's 2 corners when you get to one of the edges, so that's 4 times 2 is 8. Now this is going to be 8 divided by 4 times 4 again, because there are 4 times 4 ways you can, possibilities, and 8 possible outcomes that you want. So this is 1/2. Now we consider 3 hops. Well, there's one way you can do this, where you go to an edge, wrap around, and then go to a corner. There is no other configuration of not wrapping around, because that would leave you in like a not viable place to get to a corner, because you can't do that. So if you start from here, the center, and move up 1, well, if you go to a corner now, you've spent one of your moves and you have to get to one of these, which are not corners. So you have to wrap around and then get to these 2. This probability is 4 times 1, because the probability of wrapping around is 1. Or in this case, there's one way you can wrap around, and then you multiply by the corner, which is 2. This is 8 again. Since we're incorporating a new factor, there's the wrap arounds. 4 ways you can wrap around, 4 ways to get to an edge, 4 ways you can get to a corner. This is 8 divided by 4 times 4 times 4, which is, well, this 4 times 4 times 4. That's gonna be 6. So 16 times 4, 64, 8. So this is 1/8. And then for 4, there's 2 ways you can go about this. First hop goes to an edge, second goes back to the center, and then third edge again and corner. So it's like if you go from here, you go this block, back, here, and there. And then there's another possibility where if you go edge, wrap around, and then wrap around again, and then go to a corner. So if you start here, edge, you wrap around to this one, wrap around again, and then you have those two corner squares available. So for this one, in this case, this is going to be 4 edges times 1 center times 4 edges again times 2 corners is 32. This one, 4 edges times 1, in that case, to wrap around, because like there's only one way to wrap around once you get to an edge square. Like if you get to this edge square, for example, you can't wrap around from here since you're not on that existing block. And then multiply that by the other wraparound, and then 2 corners is 8. So you sum these two because, 32 plus 8 is 40. And 40 is basically how much cases you can go reaching a corner with 4 hops. But this probability of this is 40 divided by 4 to the power of 4. 4 to the power of 4 is 256. So 40 over 256, this is going to be 5 over 32. Yeah. So now you want to sum all the probabilities. We have this, this, and that. So the sum of 1/2 plus 1/8 plus 5 over 32, this is going to give us our answer of 25 over 32. And that's the answer for this problem.